I'm not embarrassing myself. Newton's laws. Isaac Newton was a pretty cool guy, and he was super smart. He did tons of things.
He was a physicist, an author, a mathematician, a theologist, and many other things in his lifetime.
And one of the things that he wrote were the 3 laws of motion, and that's what we're going to be talking about today.
Number 1.
An object moving at a constant speed is going to keep moving at that same constant speed until an outside force acts upon it, while an object not moving at all, will continue to not move until an outside force acts upon it.
Rule number 2.
Acceleration depends on an object's mass and the net force acting on the object. An object will accelerate on the direction of the net force. A larger mass will require a greater force than a smaller mass to achieve the same acceleration.
Rule number 3.
For every action or force in nature, there is an equal and opposite reaction. For example, when I push this penny onto this countertop, the countertop is exerting the exact same amount of force on the penny as the penny is exerting onto the countertop. To show an example of Newton's first law, we're going to be showing how an object at rest will stay at rest until an outside force acts upon it. Here we have a penny sitting on top of a card, sitting on top of a glass. When Abby here flicks the card, it's going to move out of the way, and gravity will be the outside force that will be pushing the penny into the glass.
Let me do it.
As you can see, the penny fell into the cup because gravity pushed it into the cup. Here we have 2 objects, an apple and a
Parmesan cheese packet.
Parmesan cheese packet. If we drop them at the same time, which one do you think would hit the ground faster, the apple or the packet? Seeing as though this one is heavier and bigger and has more mass, you would think this one would hit the ground first. But if you watch, they hit the ground at the same time.
In this next experiment, we are going to be proving Newton's second law.
Here we have a straw and it's bendable. So, and we have like an apple that's like pretty tough.
It's solid.
It's not easy to get into. If we use enough acceleration and force, we should be able to get this straw through this apple without damaging the straw.
Whoa!